Florida's coast is caving in. Massive sinkholes are engulfing entire beaches as ancient limestone collapses underground. This is not hurricane damage. This is not a tropical storm. This is the ground itself, vanishing into the ocean without warning. Picture waking up to find your favorite beach gone, not washed away over years. Gone. Swallowed by a 300-foot wide hole that opened overnight while you slept. Right now, tourists are fleeing hotels in their pajamas. Emergency crews are racing to evacuate thousands. 47 miles of Florida paradise are completely closed because scientists detected what they are calling catastrophic limestone failure. But here is what has geologists in complete panic. Black tar is washing ashore. Ancient material from 50,000 years ago is rising through cracks that should not exist. And seismic monitors are detecting earthquakes in Florida, a state that never has earthquakes. The sinkholes are not stopping. They are accelerating, spreading northward, and connecting through hidden underground cave networks that stretch for hundreds of miles. Is this just Florida's nightmare? Or is the entire Atlantic coast sitting on a crumbling foundation that could collapse at any moment? December 18th, 6:47 a.m. Eastern Standard Time. Coast Guard patrol boat CG-47 reports an anomaly 400 yards off Deerfield Beach. Lieutenant Commander James Walsh radios base with coordinates that make no sense. The depth finder shows 40 feet where charts indicate 12 feet. Within 15 minutes, aerial surveillance confirms the unthinkable. A sinkhole measuring 300 feet across has opened on the ocean floor overnight while Florida slept. At 7:23 a.m., the second sinkhole rips open near Pompano Beach. This one measures 450 feet in diameter. Beach erosion becomes visible from shore as the underwater void pulls sand seaward. Tourists filming sunrise videos capture the moment the beach they are standing on starts sliding toward the water. Hotel guests evacuate in pajamas, grabbing children and running as emergency sirens wail across Broward County. By 8:15 a.m., a third sinkhole tears through the seafloor near Boca Raton. The Florida Department of Environmental Protection escalates to full crisis mode. Director Amanda Torres coordinates with 15 county emergency management offices as reports flood in faster than teams can respond. NOAA aerial surveys reveal what scientists feared most. The sinkholes are not isolated events. They are connected through an underground network that is actively failing. Beach closures begin at 9 a.m. sharp. 47 miles of coastline from Port Everglades to Palm Beach are deemed unsafe for human access. The Broward County Sheriff's Office deploys 200 deputies to enforce evacuation zones, and the Coast Guard establishes no-go zones extending 2 miles offshore. The numbers are staggering and climbing worse by the hour. 12,000 tourists are displaced from beachfront hotels. 8 major resorts are completely evacuated. Emergency shelters open across Fort Lauderdale and West Palm Beach. By noon, satellite imaging from NOAA Disaster Response Division reveals the full and terrifying scope of the catastrophe. 23 distinct underwater sinkholes are identified across 15 square miles of seafloor. Dr. Marcus Reynolds, lead geologist with the United States Geological Survey, reviews the data with visible alarm. He describes what is happening as an unprecedented collapse event, unlike anything in Florida's recorded history. Preliminary damage estimates already exceed $2.3 billion, and the sinkholes are still forming. Florida sits atop a porous limestone platform that is dissolving from below. Dr. Sarah Chen, lead geologist with the United States Geological Survey, explains the chemistry behind the catastrophe with growing alarm. Carbonic acid from rainwater combines with saltwater intrusion to create a chemical reaction that literally eats the rock. A process that normally takes centuries is now happening in months. The acceleration defies every geological model in her database. Sonar mapping reveals the nightmare beneath the surface. A massive interconnected cavern network stretches from Miami to Jupiter, discovered only after the first collapse triggered emergency surveys. Some chambers measure 200 feet tall and extend for miles through the subsurface. The scale is beyond anything scientists anticipated. The University of Florida research team led by Dr. James Martinez analyzes three-dimensional models with visible distress. The limestone foundation resembles Swiss cheese, hollowed out and structurally compromised across hundreds of square miles beneath communities that have no idea what lurks below their feet. Multiple stressors are converging simultaneously to accelerate the destruction. Sea level rise is increasing water pressure at 3.2 millimeters per year above historical averages. Saltwater intrusion is weakening the limestone 40% faster than records from the 20th century. Temperature fluctuations cause expansion and contraction cycles that fracture already compromised rock. Dr. Lisa Wong at the Scripps Institution of Oceanography describes the convergence as multiple stressors, creating a perfect storm for geological failure. The observations are unprecedented and terrifying. Current collapse rates average 12 sinkholes forming per week. Historical data shows Florida averaged 2 to 3 sinkholes per year statewide. Monitoring stations detect what scientists call acoustic anomalies, the sounds of rock fracturing underwater in real time. Scientific debate erupts across research institutions. MIT researchers argue this represents accelerated geological failure driven by climate factors. The Columbia University team suggests natural El Nino cycle intensification. But both agree on one thing: the collapses are accelerating faster than anyone predicted. International geological survey teams mobilized to Florida within days. Emergency research grants totaling $45 million were approved within 48 hours of the first sinkhole discovery. On December 18th, at 7:15 in the morning, lifeguard Marcus Johnson arrives for his shift at Deerfield Beach and discovers something that makes no sense. Black tar coats the sand in thick, sticky clumps, stretching as far as he can see. Within hours, the scope of contamination becomes horrifyingly clear. 2,400 pounds of black tar wash ashore across a 12-mile stretch from Port Everglades to Pompano Beach. Emergency response teams mobilize immediately, but chemical analysis reveals these are not oil spills. The Florida Department of Environmental Protection rules out petroleum contamination within 6 hours of testing. Something far stranger is happening. Dr. Angela Martinez, a marine geologist at the University of Miami, examines samples under electron microscopy. The discovery sends shockwaves through the scientific community. The tar balls contain ancient organic material trapped in limestone for millennia. Carbon dating shows the material ranges from 15,000 to 50,000 years old. The material was released when seafloor collapses exposed deep rock layers that have not seen sunlight since the last ice age. The connection to the sinkhole crisis becomes undeniable. Tar balls appear directly above known collapse locations with disturbing precision. Maps overlaying tarball locations and underground cave networks match almost perfectly. The pattern reveals fractures penetrating hundreds of feet into bedrock, exposing geological layers that should remain sealed forever. Environmental Protection Agency teams deploy to run toxicity tests. Swimming bans extend across 31 miles of coastline. Wildlife impacts mount catastrophically. 47 sea turtles show signs of tar ingestion. 12 dolphins exhibit respiratory distress. Marine mammal rescue centers become overwhelmed within 48 hours. Scientists racing to map potential tar deposit locations discover something even more alarming. Methane readings spike in some collapse zones, suggesting additional hazards lurking below the fractured limestone. The tar balls serve as nature's alarm system, geological warnings written in ancient carbon rising from depths that should never be disturbed. If material buried for 50,000 years is surfacing now, what else could the collapsing foundation release? The ancient past is breaking through, and scientists have no way to seal it back. Maria Martinez clutches her 8-year-old daughter Sophia's hand as they stand outside their family restaurant in Pompano Beach. For 18 years, the beachfront property represented 3 generations of dreams built on Florida sand. On the morning of December 18th, everything changes. Foundation cracks appear overnight, spreading across walls like spider webs. The building inspector arrives at 9:47 a.m. with devastating news. The structure is compromised due to ground subsidence. Evacuate immediately. Maria takes 3 suitcases and family photos. The restaurant, valued at $2.8 million, carries insurance that excludes ground collapse. Sophia cries as they drive away. "When can we go home, Mama?" Coastal infrastructure fails faster than engineers can assess the damage. Highway A1A shows stress fractures near Deerfield Beach that were not there 72 hours ago. Florida Department of Transportation engineers measure 6 inches of subsidence across a 3.2-mile section. The roadway closes to all traffic. 45,000 daily commuters reroute through residential neighborhoods never designed for that volume. Emergency repair estimates reach $89 million. But no one knows if repairs will hold on collapsing ground. High-rise evacuations begin after midnight. Ocean View Towers, a 22-story building housing 340 residents, shows foundation movement detected during emergency inspections. A mandatory evacuation is ordered at 11:47 p.m. Residents are given 2 hours to pack essentials. Elderly residents requiring medical assistance struggle down stairwells as elevators shut down. Emergency shelters reach 150% capacity within hours. The Red Cross opens 8 additional facilities across Broward County. The economic cascade accelerates beyond containment. 2,400 hotel rooms closed indefinitely. 67 restaurants shuttered as evacuation zones expand. Spring break bookings canceled with projected losses reaching $420 million. A mental health crisis emerges alongside the geological catastrophe. Children wake screaming from nightmares of the ground opening beneath them. Anxiety medication prescriptions spike 340% across coastal counties. The mayor of Fort Lauderdale faces cameras with visible exhaustion. This is beyond anything we planned for, beyond anything our emergency protocols imagined possible. December 20th, 2:34 a.m. Eastern Standard Time. A magnitude 2.8 earthquake strikes with an epicenter 15 miles offshore from West Palm Beach. Dr. Kevin Torres, USGS seismologist, stares at data from monitoring stations with complete disbelief. This should not be happening. Florida averages 0 significant earthquakes per year. The state sits nowhere near tectonic plate boundaries. Yet this month alone, seismic monitors recorded 17 detectable tremors across the region. A magnitude 2.5 earthquake struck near Panama City. It was the largest seismic event in Florida in a decade. The connection between collapses and earthquakes defies traditional seismology. These are not tectonic plate movements. Something entirely different is occurring beneath Florida's coast. The leading theory suggests the massive weight of collapsing rock creates stress waves that propagate through the limestone platform. A secondary theory proposes water rushing into newly formed voids generates pressure shocks powerful enough to register on seismometers. Dr. Rachel Kim at Caltech reviews the seismic signatures with growing alarm. We are observing new phenomena that earthquake science cannot fully explain. Emergency monitoring networks deploy across the crisis zone. 40 temporary seismometers were installed along 100 miles of coastline within 48 hours. Real-time data stream to USGS headquarters in Golden, Colorado. The sensors detect continuous micro-tremor activity, constant vibrations suggesting progressive collapse spreading through interconnected cave systems. The pattern moves steadily northward at rates averaging 3 miles per day. The seismic reach extends far beyond initial projections. Tremors registered in Miami, 85 miles south of the primary collapse zone. Jacksonville reports unusual vibrations felt by residents 180 miles to the north. Georgia places monitoring systems on high alert. South Carolina requests federal assistance for geological assessments. Computer models project disturbing possibilities. Simulations show potential for magnitude 4 or larger events if collapses accelerate. University of Miami researchers run cascading collapse scenarios showing worst-case magnitude 5 earthquakes possible if multiple cave systems fail simultaneously. Earthquake preparedness campaigns launch across Florida, unprecedented for a state never considered seismically active. Building codes face emergency review. The impossible is becoming reality. Limestone formations do not respect state boundaries. The same geological platform supporting Florida extends through the entire southeast coastal region. Georgia sits on identical porous limestone. South Carolina contains karst topography, riddled with underground voids. North Carolina's Outer Banks show early warning signs that scientists previously dismissed as normal erosion. The Atlantic coastal plain stretches 1,200 miles from Florida to New Jersey. All are potentially vulnerable to catastrophic collapse. Early detection systems activate along the coast as the threat expands. The Georgia Department of Natural Resources deploys emergency survey teams to barrier islands within 72 hours of Florida's first collapse. Jekyll Island reports minor subsidence detected in 3 separate locations. Tybee Island experiences unexplained beach erosion, accelerating beyond historical rates. South Carolina's governor requests immediate federal geological assessment. The USGS expands seismic and ground monitoring networks to 6 states. Dr. Michael Torres at Duke University proposes the domino effect theory with supporting data that alarms coastal researchers. Florida's collapse is creating regional destabilization through interconnected geological systems. Pressure changes in the massive Florida aquifer affect connected regions across state lines. Groundwater flow patterns shift dramatically, altering subsurface conditions hundreds of miles from the original collapse zone. The aquifer system extends from southern Alabama to South Carolina. The potential for cascading failures stretches across the entire southeast. Economic implications explode beyond initial projections. Atlantic coast tourism generates $186 billion annually across affected states. Real estate values in 15 coastal counties total $2.4 trillion in assessed property. Federal Reserve economists analyze scenarios where the spreading collapse could trigger an economic catastrophe dwarfing the 2008 housing crisis. The insurance industry convenes emergency summits in New York and London. Lloyd's of London reclassifies the entire Atlantic limestone coast as extreme risk, essentially uninsurable under traditional coverage models. International attention focuses on Florida as a global warning. The Bahamas sits on identical limestone formations. Caribbean islands face similar vulnerabilities. Mexico's Yucatan Peninsula contains the world's largest underwater cave systems. Mediterranean coastlines monitor developments closely. Florida's nightmare is becoming the world's concern. On December 19th, Governor Ron DeSantis declares a statewide emergency from the Capitol steps in Tallahassee. The formal request submitted to the White House demands $12 billion in federal disaster relief. It is the largest single-state request in FEMA history outside hurricane season. The Florida National Guard receives mobilization orders for 4,200 personnel. It is the largest domestic deployment the state has ever authorized. Troops establish checkpoints, coordinate evacuations, and patrol closed beaches to prevent unauthorized access to collapsed zones. A congressional battle erupts within hours of the federal funding request. House Republicans question the allocation during emergency appropriations hearings. Why should taxpayers across America bail out Florida's coastal development decisions? Senate Democrats push for immediate approval without conditions, arguing that American citizens are suffering now. The debate over climate change's role in the crisis paralyzes legislative action. Senator Marco Rubio faces cameras with visible frustration. People are losing their homes while Washington plays politics. The emergency funding bill stalls in committee as both parties calculate electoral advantages. FEMA faces resource exhaustion across multiple simultaneous disasters. The agency deployed thousands of personnel to California's catastrophic floods just weeks earlier. Administrator Deanne Criswell warns Congress that FEMA cannot maintain the current operational pace without additional funding. Emergency reserves deplete at unsustainable rates. The insurance industry approaches systemic collapse. Citizens Property Insurance, Florida's state-backed insurer of last resort, faces insolvency as claims exceed $18 billion in the first week alone. Private carriers cancel 340,000 policies across coastal counties, citing ground collapse exclusions buried in policy fine print. Homeowners discover their coverage excludes the exact disaster destroying their properties. Property markets freeze completely. Coastal sales drop 91%. Mortgage lenders refuse new loans within 10 miles of documented sinkholes. $67 billion in assessed value disappears from tax rolls within 2 weeks. Tourism devastation spreads beyond beach closures. Disney World revises attendance projections downward by 22%. Miami Beach hotels report 83% cancellation rates extending through summer 2025. Annual tourism losses are estimated at $43 billion. 340,000 jobs are threatened across Florida's service economy. 1 week after the first sinkhole opened off Deerfield Beach, Florida's coastal crisis shows no signs of ending. The numbers tell a story of devastation that continues to grow. 47 miles of coastline remain closed to the public. 23 documented sinkholes scar the seafloor across 15 square miles. Damage estimates exceed $25 billion and climb higher every day. 78,000 residents remain displaced from their homes, sheltered in facilities never designed for long-term occupation. The seismic tremors continue spreading northward at 3 miles per day. Scientists track the progression with growing unease as vibrations register in states that never prepared for geological instability. Georgia, South Carolina, and North Carolina activate monitoring systems for threats that seemed impossible just weeks ago. Recovery operations face the grim reality that this disaster defies conventional response. Unlike hurricanes, which pass and leave damage to repair, the sinkholes represent ongoing geological failure with no clear endpoint. Engineers cannot rebuild on ground that continues to collapse. Insurance cannot cover losses that policies specifically exclude. Government cannot fund relief that exceeds emergency reserves already depleted by disasters elsewhere. The limestone foundation that seemed eternal reveals its terrifying fragility. Centuries of stability created false confidence in ground that was slowly dissolving beneath the surface. Climate scientists warn this may represent acceleration beyond worst-case projections. The stressors converging on Florida's coast are not temporary conditions, but permanent features of a changing world. Community resilience emerges as the most powerful force amid the chaos. Neighbors helping neighbors. Churches opening doors to displaced families. Volunteers coordinate relief efforts that overwhelmed government agencies cannot provide. The human capacity to respond to crisis offers hope that Florida will rebuild. But individual generosity cannot address systemic geological collapse. The same limestone extending up the Atlantic seaboard sits beneath millions of homes and billions in infrastructure. 3 nuclear power plants operate in zones now classified as vulnerable. Military installations supporting Atlantic Fleet operations rest on foundations that may be compromised. The Port of Savannah, America's 3rd busiest, was built on rock that dissolves. The questions raised by Florida's crumbling coast remain unanswered. How many more sinkholes will open before the crisis ends? How far north will the collapses spread? Can communities rebuild on ground that continues to fail? Will the insurance industry survive claims that exceed all projections? And perhaps most troubling of all, is this just the beginning? The sinkholes have stopped growing for now, Emergency crews work around the clock to assess damage and coordinate response. Scientists analyze data that rewrites understanding of geological stability. Politicians debate funding, while citizens wait for help that may never fully arrive. But beneath the surface, the limestone continues to dissolve. The ancient rock that supported paradise for generations keeps revealing just how fragile it really was. The ground that seemed so permanent is not permanent at all, and Florida may never feel solid again.